let's graph a few more rational functions. So I suggest you pause the video and try and graph, and then check back with me to see if I agree. So let's start with the domain. Which would be all real numbers. X is not 0 or -5. Checking for a removable discontinuity, we can cancel the monomial x with the monomial x. So we have a removable discontinuity at 0, and we plug that into our simplified version, 2 over x plus 5, and get 2/5. We still have a vertical asymptote at x equals -5. The denominator has a higher degree, so there is a horizontal asymptote at y equals 0. A table of values, either from my calculator or from my head, it's going to have to center around -5. So -6, -7, -8, maybe -4, -3, -2. This is our vertical asymptote. So -8 would be -2/3. -7 is -1. -6 is -2. -4 is 2. -3 is 1. -2 is 2/3. And we can't forget about our removable discontinuity at 0 2/5. All of these numbers are reasonably small, so I'm going to count by halves. So if I want, well, my vertical asymptote is at -5, so 1, 2, 3, 4, 5. So I guess I'll count by ones. My horizontal asymptote is at y equals 0. I have a hole at 0 2/5. The rest of my points look like -8, -2/3, 7, -1. And if I need more, I will go get more. Let's come down on the underside. On this side, we have -4, 2, -3, 1, 2/3. Definitely in the path of the hole. And traveling up the vertical asymptote. Okay, hopefully that's what you have. Pause the video and try this one. We have domain, all real numbers. X is not -3. The numerator actually factors into 2x plus 1, x plus 3. So my x plus 3's will cancel. I have a removable discontinuity at -3. And then I plug that in. So -6 plus 1 would be -5. My simplified version is just 2x plus 1 with no denominator. So at this point I realize I have a line with a hole in it. The hole is at -3, -2, -5. The y-intercept is 1, and the slope is 2. indeed, it is a line with a hole in it. Very nice draw. Our third example. Pause the video and try. Our domain, all real numbers, except x is not -1. The numerator will not factor, so we do not have a removable discontinuity. Instead, we have a vertical asymptote at x equals -1. The power in the numerator, the degree of the numerator is higher than the degree of the denominator, so there is no horizontal asymptote. There is, however, a slant asymptote. At 2x plus 5. So y equals 2x plus 5. I made a table of values in my calculator, and I'm just going to share with you the values I got. I centered my table around -1, and the values I chose were for -2, -3, -4, and then -7 just for fun. And then 0, 1, 2, and 5 just for fun. So -7 was at -8.5. -4 was at -2. -3 was at 0.5. And 2 was at 4. 0 was at 2. 1 was at 5.5. 2 was at 8. And my fun point, 5 was at 14.5. So I need some up and some down. Let's see, 14, 2, 4, 6, 8, 10, 12, 14. So let's start here. Okay. So my vertical asymptote is at -1. And just let me put a few points down. My slant asymptote is at 2, 4, 5 with a slope of 2. Okay. I may need, okay. Right. -7, 2, 4, 6, 7, was at -8.5, 2, 4, 6, let's see, 2, 4, 6, 7, 2, 4, 6, 8.5. -4, 2, 4 is at -2. -3 is at 0.5. -2 is at 4. Okay, so we can see this running very close. And again, get more points if you need them. And on the other side, we have 0 is at 2. 1 is at 5.5, 2, 4, 5.5. 2 is at 8, 2, 4, 6, 8. And 2, 4, 5 is at 14. 2, 4, 6, 10, 12. 6, 8, 10, 12. 14.5. So again, we're hauntingly close.